Welcome back, grade 12 seniors, and this is your lesson 2 for term 1, and the title of this chapter is heat. As you know from before, what is heat? We said before, heat is energy that flows from hot objects to cold objects. Okay, and the unit of heat, بما انها heat is energy, so its unit is joules or kilojoules. One way to measure or calculate the heat was Q equal M times C times delta T. And we said Q might be positive or negative. If it is positive, this means the reaction is endothermic or absorbs heat. And if it is negative, this means the reaction is exothermic or releases heat. Okay, so this is a summary of what you have learned from the previous lesson. Now let's continue. Pause through these objectives, read them if you want, and these are the objectives that you are going to learn during this lesson. Okay, now when we say calorimetry, from its word, calorimetry means measuring calories. Okay, so this is a system used to measure calories. You have few links that you can use if you want to watch some videos related to the topic, you can watch them. Okay, now we have two types of calorimeters. The first one is the coffee cup calorimeter and the second one is bomb calorimeter. Now there are certain common things between the coffee cup calorimeter and the bomb calorimeter. Now in the coffee cup calorimeter, we have a thermometer, and here we also have a thermometer. Now the thermometer will measure the temperature. Actually, we should have two temperatures. Temperature before we start the experiment, which we call it T initial, and the temperature after the experiment, which we call it T final. And when we minus T final minus T initial, we can get delta T. Okay, we have this one. This is used as a stirrer to mix the containers. We have a styrofoam cup or this cup. Very important that this cup is insulated. Why it should be insulated or isolated? So that no heat will be lost to the surrounding. Okay, now in the coffee cup calorimeter, this is similar to the coffee cup that you use to drink coffee, the styrofoam white cup. What do? We put the first reactant, and then we measure the temperature, the initial temperature, and then we put the other reactant, and then we cover them so that no heat is lost, and we measure the increase in temperature. Then how do we calculate Q? Q is equal to M times C times delta T. It is very important to remember that if we are using aqueous solutions, which means water, the mass is equal to the volume. Okay, and the specific heat will be 4.18 because aqueous means water. Now delta T is measured by using the rule of T initial and T final minus T initial. Okay, now we have the second type of calorimeter, which is called a bomb calorimeter. Now this bomb calorimeter is used to measure calories in food. This one is used to measure calories or energy in reactions, where we put the first reactant, and then we put the other reactant, and then when we mix them together, we see the temperature might increase or it might decrease. It depends on if the reaction is exothermic or endothermic. Now the bomb calorimeter is used to measure calories in food. How do we measure calories in food? Like if we have a piece of bread and I want to know how many calories are in this piece of bread, so I put it inside this container. I put the bread piece here. And then using these wires, the ignition wires will burn the bread. And when the bread burns, it will release heat. The fire will release heat. The heat will pass through the container to the water. The temperature of water will increase. So, as we said previously, we will record the temperature of water before we burn the bread and say this is T initial by using the thermometer. And then by using the ignition wires, we will burn the bread and the heat will be released. And then we will record the temperature as T final. And then we will use T final and T initial to calculate delta T. Okay, and the mass will be the mass of water in here. And the C will be 4.18 for water. And then we can calculate Q. A very important link that can be used to determine this experiment is this one. Let me share with you this link. This is Pearson calorimetry. Actually, this one has a virtual experiment that it can be done online. Okay, I'm so sorry if this is going to be late, but it seems that there is something going on. So whenever you press on this experiment, calorimetry, you do experiment and you press on run experiment. Now let's do one experiment. For example, if I want to do an acid-base experiment, so I will choose from here liquid. I will choose, let's say, okay, let's say water here. How much is the mass of water? I will choose. Okay, let's make it a solution. Now in the solution, let's say I have acid, HCl. I will choose a certain volume of the acid. Let's say I have chosen 100 milliliters and the concentration of the acid is 1.6. Now the specific heat is 4.18. It is similar to the water specific heat because here it says aqueous. Whenever I say aqueous, this is dissolved in water. Okay, now this is the first solution, 100 milliliters. Notice that 100 milliliters from here is equal to 100 grams. Okay, now next, I will choose the other solution. I will choose a base. I will choose, for example, an AOH. Okay, I will choose the volume to be also 100 milliliters, the concentration to be 2, and the specific heat is again 4.18 because this is aqueous. Okay, now notice that both of them are at 20 degrees Celsius. When I mix this one with this one, do you think the temperature will stay as 20 or it will increase or it will decrease? Okay, let's see. So here in this container, I have HCl, which is an acid. And here in this container, I have an AOH, which is a base. Now, both of them are at the same temperature. Now, let's press on next and see what will happen when we mix them together. Okay, now the acid will go to the base. بسرعة we will cover so that no heat is lost, and then we will observe the temperature. Now, what did you notice? What is the final temperature? Now, this is the final temperature for both the acid and the base because both of them are here. Now, the final temperature is 30. Before the experiment, it was 20, and now it is 30. What does it mean? It means that the reaction released heat and the temperature increased. I did not heat it. The reaction released heat and it caused the temperature to increase. It was 20 and now it is 30. So how much is delta T? Delta T is around 10 degrees, 10.90 degrees. So this reaction is exothermic or endothermic? For sure it will be exothermic because the temperature increased. Okay, now this is one experiment that you can do. You can try, you can type this link and you can try to do this experiment by yourselves. Okay, now another experiment that we can do using this is we can use a solid. For example, let's choose silver and I will choose a mass of silver equal to 35. See, as when I increase the mass, the size of the cube will increase. Okay, let's say the mass is 50 and the temperature is 200 and the specific heat is 0.23. Now this is solid, this is not aqueous, so the specific heat will not be 4.18. Okay, now what I will do is I will put this in a liquid. طبعا I will choose water. I will fill this one with water. Okay, let's choose a mass of water equal to 200 grams. Now again, notice 200 grams is equivalent to 200 milliliters. Now, remember, I have two things. I have a metal. The mass of metal is 50. Its initial temperature is 200 and its specific heat is 0.23. Now, the other thing I have is water. I have 200 grams of water. The temperature is 20 and the specific heat of water is 4.18. Now what I will do, I will put the block in water. Now when I put the block in water, they are at different temperatures. What will happen to the temperature of the block? طبعا, we will have to reach a final temperature between this one and this one. So the block will lose heat. And the heat will be transferred from the hot to the cold to the water. And the water temperature will increase. So this is what is expected. We expect this one to lose temperature and be less than 200. And this temperature will increase to be more than 20. Okay, so let's say next and let's start. Now the block is put into the water. Now we mix and we stir and we record the final temperature. Okay, now the final temperature is 22.49. Remember, before it was 20 and now it is 22. This temperature was 200 and now it is 22. This 22 is for both of them, the metal block and the water. Okay, طب دائما you will notice إنه the final temperature will be closer to water. It will not be closer to the metal. يعني the temperature of water was 20 and now it increased only to 22, 2 degrees. Why? Because the water have high specific heat, which means it will not get hot easily and it will not get cold easily. Okay, so the final temperature will not be midway between 200 and 20. It will be closer to 20. Now I will use this slide to do some calculations. Let me show you the calculations that you will have to do here. Okay, so the calculations that you will do is, first you have to remember that I have two things. I will separate them. I will write the metal here and all the information related to the metal, and I will write the water here. Okay, now for the metal, the mass of metal is 50 grams. The T initial is 200. And the specific heat C is 0.235. Now the final temperature is 22.49. I can use all this data to calculate Q. Q equal M times C times delta T. Okay, M is 50, C is 0.23, and delta T is 22.49 minus 20. Okay, this is 20 degrees Celsius. Okay, so 200 minus 22.49 minus 200, this is the way we get delta T. Now for water, I have the mass is equal to 200 grams and the initial temperature is 20. The final temperature is 22.49. Okay, and the specific heat C is equal to 4.18. I want you also to calculate Q. Now, when you calculate Q here and Q here, Q equal M times C times delta T. This Q should be equal to this Q and opposite in sign. Now the metal, the temperature was 200, it dropped to 22.49, so I will say that here is Q lost. The water was at 20, increased to 22.49, so this I will say this is gain. So when you calculate this Q and you calculate this Q, you will find out that Q lost will be equal to minus Q gain. This is the law of conservation of energy. Calculate Q here and calculate Q here and check what I am saying. And when you finish, you can go to this link, choose any metal you want, put it at any temperature you want, and then drop it to water and then calculate Q in each case and compare it. Okay, so this is the way a calorimeter works. Okay, let's say this experiment. A student mixes 50 milliliters of HCl. This is the first experiment that I've done with you. I have 50 milliliters of HCl and 50 milliliters of NaOH. Okay, can we find the total volume? The total volume is equal to 50 plus 50, which is equal to 100 milliliters. And when I say 100 milliliters, this means the mass is equal to 100 grams. Okay, and notice that the temperature rises from 21 to 27.5. Now, what is this 21? What is this 27.5? This is T initial, this is T final. Can you find delta T? T final minus T initial, which is equal to 27.5 minus 21, 6.5 degrees Celsius. Now remember, when I'm saying HCl and NaOH, this is aqueous solution, so the specific heat is equal to 4.18. Now calculate the enthalpy. Enthalpy is heat, which is Q. Q is equal to M times C times delta T. M is 100, C is 4.18, and delta T is 6.5, and then you calculate Q. Okay, now try to pause the video and answer this question. A 25 grams block of an unknown metal X was heated to 95 and then immersed in water. So I have two things. I have a block and I have water, and I don't want to mix the two. I have a block and I have water. Now, what information did he give you about the block? The mass of block is 25 grams. and it was heated to 95, so this is the initial temperature, and then immersed in 13 milliliters of water. Remember that the volume is equal to the mass, so milliliter is the same as grams, so the mass is equal to 13 grams. At 25, so this is the initial temperature. When the two substances reach equilibrium, the final temperature was 32. Remember, this temperature is for both because I put the block in water. So T final is equal to 32 and T final is equal to 32. Now, what is the specific heat? He wants to see this one, how much, and this C is 4.80. So how will you solve this question? طبعا the block temperature dropped from 95 to 32, so here Q lost. The water temperature increased from 25 to 32, so this is Q gained. They are equal and opposite in sign because one of them is lost, one of them is gained. So I will say here for the block, M times C times delta T, all this is for the block, is equal to minus M times C times delta T, and all this is for water. Now let's put the values, 25 times C times delta T, 32 minus 95, this is 63. Okay, so this is 63 is equal to, we have minus 63, is equal to minus the mass 13 times 4.18 times 32 minus 25, 7, and then you will get C. Okay, C should be a positive number. C will be 0.24. It should be a positive number, and it should not be more than 4.18. You know very well that the specific heat of water is the greatest specific heat in all these substances. So the specific heat will not be more than 4.18. Okay, now pause the video and do this question. Okay, now again pause the video and do this question. Okay, now this is another question. 25 gram block of unknown metal X was heated to 95 and then placed in water. This is similar to what we solved before. So the temperature of water is 25 degrees Celsius and the temperature of the block was 95 degrees Celsius. Okay. First question, draw an arrow showing the direction of heat transfer. طبعا heat moves from hot objects to cold objects. So it will flow from 95 to 25. Calculate the specific heat of the unknown metal. Same what we've done. You will do Q of metal equals minus Q of water. M times C times delta T for metal is equal to minus M times C times delta T of water. And then you will do the calculation and find the specific heat. I think it will be 0.2. Let me see. 0.24. So the answer will be 0.24. Okay, another question. Now, what is thermochemistry? Thermo means heat. Whenever you see the word thermo, this is heat. And what is chemistry? Chemistry is chemical reactions. Okay, now when you say thermochemistry, this is heat in chemical reactions. And as we said before, chemical reactions are two types. Imma they are exothermic or endothermic. So when I say exothermic, and this is endothermic. In exothermic, heat is released. So whenever it is released, we say this is the system and outside is the surrounding. الرياكشن هو السيستم واللي حواليه هو surrounding. Okay. طب in case of endothermic reaction, heat is absorbed. So whenever I say heat is absorbed, so heat goes from the surrounding into the system. Okay, so the system absorbs the heat, so the heat goes from the surrounding to the system. Now, system plus surrounding, they do what I call universe. So universe in chemistry is the system plus surrounding. Okay, let's do this practice. You have this. You have to identify in this which one is the system and which one is the surrounding. and which one is the universe. Okay, طبعا as you know, the system is the reaction. Who is doing reaction here? CaCO3 and HCl. So this is the system. Now the surrounding is the flask, and you can say the air around the flask. Okay, all this is the surrounding. Conical flask plus air. Now the universe is both of them, system plus surrounding, which is the CaCO3 and HCl and conical flask and air. So universe in chemistry is everything at the same time. Now enthalpy is another word for heat. Okay, and its symbol is delta H. Okay, طبعا whenever you say delta يا guys يا grade 12 يا seniors, delta means final minus initial. So when I say delta H, this is H final minus H initial. In chemistry, final is products and initial is reactants. As you know, reactants become products. So the final is products and the initial is reactants. So delta H is equal to H final minus H initial, or H products minus H reactants. Okay? Now take a moment to look at this slide. Also take a moment to answer these questions. Okay, now these two graphs. Let me explain to you these two graphs. There are two graphs, two types of energy diagrams. You either have this graph or you have this graph. As you can see here in this energy diagram, this line is going down. So I say this is losing energy. This is exothermic energy is released. Whereas when we go this way, this one is going up. So this one is gaining heat or endothermic. So whenever it gains, we say this is endothermic. In endothermic, delta H is positive. In exothermic, delta H is negative. Now I need to label these places. طبعا what we start with is reactants. What at the top of the curve, we have the activated complex, and at the bottom we have products. Now same thing applies here, reactants, and at the top we have activated complex, and here we have products. طيب هلا the distance from here to here, يعني كأنك you are here and your house is here. This distance is called AE. Now what is AE? AE is activation energy. AC is activated complex. Okay, AE is activation energy. Okay, هلا here the activation energy, you are here and this is your house. Okay, the activation energy is all this distance. Okay, so this is called AE. Sometimes they ask you to label the graph, and sometimes they ask you what is the letter of each one. Okay, let's do practice on this. We can do the practice on this question by doing okay, let me find the question that you are supposed to answer. This one. If we have this question and I want to label each one of them, and at the same time, after labeling, I will want you to tell me in numbers how much is each energy. Okay, so let me place it here. Okay, now let's label. At X, طبعا, what do we label? We label reactants. At the top of the graph, this is activated complex, and here we have the products. Now you are here and your house is here. What is the activation energy? Activation energy is M. Now N is the distance from reactants to products. Reactants to products, this is called delta H, or the enthalpy. Now if I want to answer in numbers, how much is the heat of reactants, products, activated complex, how much is AE, and how much is delta H, and I want to tell if the reaction is endothermic or exothermic. Okay, let's start. Now, reactants are here, so their heat is 100. What is the unit? Kilojoules. So reactants energy is 100 kilojoules. Now, products, if you go here, it is 300 kilojoules. Okay, now AC is here, its energy is 400 kilojoules. Okay, now AE is the distance from here to here. One common mistake is that students say AE is 400. This is not correct. AE is from here to here, not from the bottom. So from 100 to 400, from reactants to activated complex. So how much is this distance? This is 300 kilojoules. Okay, now delta H is heat of products minus heat of reactants. HP minus HR, which is equal to 300 minus 100, which is equal to 200. طبعا kilojoules. Now, is the reaction endothermic or exothermic? As you can see, it is going up. This is gaining. This is endothermic. In endothermic, delta H should be positive, which we already calculated here. Okay, one other question that might come to you in the exam, which is a little bit more difficult than this one, they ask you about the reverse reaction. When I say reverse reaction, this means now you are here and you are going back. You are standing here and you are walking all this way to here. Now this is your house. Okay, now how do we label? طبعا we start here. Now, this will be the reactants. This will stay as the AC and this will be the products. Okay, now the height, the AE will be from here to here only. Okay, so from 300 to 400, this is the AE for the reverse reaction. Delta H will be the same because it's from reactants to products, so it will be the same. Okay, but for the reverse reaction, we are going down. So this is losing heat, so this is exothermic. Okay, so the reverse reaction is exothermic because we are going back and we are going down, so this is losing heat. So you have to be careful in the exam if they are asking about the forward reaction or the reverse reaction. Now this is the lesson, the end of lesson 2. Thanks for watching.